In LUSAS version 19.1, we've extended our assessment or rating codes in the Vehicle Load Optimizer to include CS458 with Assessment Live Loading Model 1 for our UK market, and AASHTO Manual for Bridge Evaluation, Load and Resistance Factor Rating for our American market. The implementation for both of these codes allows the user to add their own custom vehicles to be considered in the optimization process. In this model of a steel concrete composite bridge in the UK, created using the Steel Composite Bridge Wizard, the deck slab and girder webs are modelled as shells, while the girder flanges are modelled as beams. I've then created slices in order to cut across the different elements, integrating the stresses in each to get the total effects, such as bending moment, on the composite beam. I can then define a bending moment influence for the slice, choose which slices to assign it to, and I'll then be able to optimize for bending moment on the composite beam. If I select the curb lines, I can then run a vehicle load optimization. I'll be doing this to CS458 with Assessment Live Load Model 1. As well as being able to select the vehicles defined by CS458, I can also specify my own custom vehicle. This is just an example vehicle. Having defined an example vehicle, I can inspect it for optimization the same way as any other vehicle. I'm only going to do ULS combination 1 just for speed within this demonstration. By default, LUSAS will output information only for the worst vehicle. However, if I limit the speed of transit and the loading options to being only a single vehicle or only a convoy, I can ask LUSAS to give me results for each vehicle individually. I'll check all influences, looking at both positive and negative effects. Click Define Carriageways to let LUSAS know that the lines I've selected are the curbs, and I'm also going to create loading patterns for the most onerous, so one loading pattern for the biggest span moment, and one separate loading pattern for the biggest pier moment. We can see here that a maximum moment of 1,832 kilonewton meters was found over the pier, with a maximum moment of minus 2,100 kilonewton meters found in the span. Looking at the load patterns, we can see that over the pier, the most onerous pattern was to have the SV80 vehicle in one lane with a convoy of F2 vehicles in the other lane. For the span, an SV80 in one lane with a single vehicle D2 in the other lane was found to be the most onerous. Switching to a suspiciously similar bridge in the United States, you can tell because the units have now changed to kips and feet. We can go through a similar process if we select the curb lines and run a vehicle load optimization. And this time, if we select the United States of America and AASHTO MBE, once again we can do custom vehicles. This time we have the option for both legal loads and for permit loads. The vehicle definition dialog is the same for both, but where the loads appear in the VLO code dialog differs, either in the routine traffic selection or in the permit selection, and therefore the way they're treated and the factors applied to them does differ. We'll run our optimization for Strength 1 inventory and legal load. I've already defined a custom legal load similar to the one I did for the UK, and I'll use default options for the rest of the settings. I'll check all influences, but I'll only look at positive effect, which is pier moment in LUSAS sign convention, and tick alternative load pattern, which means that 90% of 2 trucks will be considered. Looking at a load pattern generated, we can see that for the legal load strength 1, that our example vehicle is actually the most onerous loading. For specialized haulage vehicles, the notional rating load is the most onerous. For emergency vehicles, an EV free in one lane or a Type 3 free and lane load in the other lane is most onerous. Whereas for design load inventory, 90% of 2 trucks in each lane has been found to be the most onerous. The custom vehicles are defined in the Utilities tab, from where they can be edited if need be. They can also be imported and exported using the import-export function built into LUSAS.